Hello again, friends. This is Jay Brains, coming to you with fundamentals of test-driven development and evolutionary design and high-discipline programming. We've been starting the sell one item feature of the point of sale system. Take a look at our code. We can see that what we've implemented so far are tests for what happens if we find a product and what happens if the product is not found. And we use the triangulation method to help us generalize our algorithm for the case where we find a barcode, we find a price corresponding to the barcode that comes in. And we use a different technique for the product not found case where we faked it till we maked it and then remove duplication between the production code and the tests. So now I'd like to go back. Our test list, we have empty barcode and null barcode to think about, and we also have a refactoring to think about introducing a lookup table. If we look down at the sale class, we can start to see the pattern that evolves here. If we duplicate these else-if statements, we can see that we are effectively encoding a lookup table that maps barcodes to prices using control structures, which is definitely a bad idea. Abstractions in code, details in data, and when we put details in code, we violate the open-closed principle, we violate the dependency inversion principle. In fact, we probably even violate the Geneva Convention, I'm not entirely sure. So let's go back to our tests now. We can introduce the lookup table now, or we can make some more tests pass. If I'm not 100% sure that I'm ready to refactor something, then I add maybe one more test until that becomes a bit clearer. As you practice test-driven development, you'll probably have a tendency towards premature generalization. It afflicts a lot of programmers, and the best way I know to deal with that is to gather more evidence. You can gather more evidence by reading more code, by talking to people, or by writing more tests. So let's do that. The reason that I want to consider empty barcode has everything to do with, if you can imagine, user experience. Imagine what happens with our code now. In fact, we don't have to imagine. Let me back this out. What happens if our barcode is empty? Well, certainly we're not going to find a product for that barcode. But the error message, you can see over here, the message is product not found for, and nothing. And I don't know about you, but if I were a cashier or a customer and I saw that on the cash register display, I would freak out because that looks like a mistake. And in fact, I think it is a mistake. So we definitely want to handle the empty barcode as a special case. So let's do that. Of course, we need our intrepid customer to tell us what the result should be, and I can put my customer hat on right now and say that what I'd like to see is scanning error, empty barcode. By the way, since I wasn't necessarily around to answer these questions for you, you might have chosen differently for how to display a product not found, how to display an empty, and then this empty barcode issue might not have come up. That's cool with me. Don't worry about it. If you decided differently, that's fine. If it reaches a point where I think it's really important, then as a customer, I will tell you. And of course, if you weren't sure and you didn't ask your customer, maybe next time you should ask your customer. All right, so let's try scanning error empty barcode. That indicates to the user that this is a real problem and not just that the problem is in the scanning. Maybe it's in the barcode scanner itself. Maybe it's in the barcode that we're scanning, that the barcode is printed incorrectly, which is definitely different from, say, scanning a barcode, expecting there to be a price, and not getting one. So if I have a product in my hand with a barcode 5678, and I scan it, and the message I see is product not found for 5678, then I know the problem is somewhere in the system. I haven't put a price in for that barcode. But if I scan that same barcode and I get scanning error empty barcode or product not found for a bunch of garbage, then I know to just try scanning again. So let's try to, we'll try to make this a little bit easier for our users. So of course, this will happen when we scan an empty barcode. And I would like my good friends over here again. By now, you're probably screaming at the screen for me to move those the sale and display into a test fixture. Yeah, you're right. Let's run the test and watch it fail. And now let's make it pass. So again, I'm going to use the really simple, straightforward technique of add the new special case. See, display set text. Otherwise, do the old thing. And the fact that it's a double nested if statement is not a big deal for just this second. All right, that passes. So let's check that in. And now, only because we just handled the empty case, by the way, I can cross that off my test list now. Let's think about the null case now. So I don't want to get into overly defensive programming. In fact, one of my basic guiding principles, just like moving details up the call stack, is to move defensive programming tactics up the call stack. I'd like to get to the point where it's impossible, or at least a justifiable crash for null to get into this system. Now, null is an interesting special case because it's so common and it's so destructive. Now, the good news is that well-designed systems won't let null propagate through, or at least will barf at some point on null. And that barfing, that crashing, might be okay, but we'd like to do better if we can. And of course, it depends where the null comes from. If the null is coming from the outside world, then we really need to do something to combat it. But if the null is coming from one of our fellow programmers, somebody on our team, then perhaps what we should do is push the responsibility up the call stack for them to ensure that they don't send us null. And if they do, then they deserve what they get. Now, I'm not a big fan of garbage in, garbage out, but I'm even a less a fan of high-grade, prolific defensive programming. I've seen systems where literally 60% of the code is trying to deal with invalid input at every level of the system. And if you've ever worked in a system where a single null reference results in a cascade of null pointer exceptions thrown up the stack, where the stack trace is 10 exceptions deep, all chained inside each other, that's madness. I don't want that to happen either. What I'd rather do is create trusted zones in the code where we know null doesn't get in, and then push those trusted zones as far up the call stack as possible. In this case, I'm actually not going to worry about null for one very simple reason. I've been using this QCat barcode scanner for several years, and it has never ever sent me null. In the very, very worst case, it sends me either an empty string or a string with garbage in it, but it never sends me null. So I'm going to conclude from that the barcode scanner is never going to send me null, and I'm not going to worry about it. Now, that probably sounds like a naive conclusion to you, but I'd like to use it as a convenient fiction for now, even if you don't agree with it. And if you want to implement the null case to check for it, that's fine, just as long as you look for ways to push that null check up the call stack later on. We'll talk about this later, something called the bouncer pattern that I like to use for data validation. I'm sure that you already know it and you've probably heard it under different patterns, but I like the bouncer pattern because it's a nice metaphor. All right, let's get back to the code. We've now dealt with the empty case. We're going to not worry about the null case for now, so I'm just going to circle that on my test list and defer that to later. But now's a good time for us to do our refactorings. We don't have any more tests on our test list, but we do have a refactoring on our test list that we need to look at, so let's do that now. And that's introducing a lookup table. This is a way of removing duplication in our code. As I have mentioned earlier, and you've no doubt seen now a few times, in order to add more barcodes and prices to our system, we would need to duplicate the branches of this if statement. So you can think of this intuitively as a problem that I have to change code in order to add new products, which is something that I should be able to do just by inserting data into the system. That's, again, the open-closed principle, right? There's no reason for us to have to change this code in order to add more products. The mechanical way you can think about it is that by adding this code, I'm creating some pretty serious duplication in the structure. If the barcode is X, then set the text to Y. If the barcode is Z, set the text to A. If the barcode is B, set the text to C. So let's remove that duplication now while we can. And the way that we're going to do that is by introducing this lookup table. It's been said of chess that it takes 5 minutes to learn the rules, but a lifetime to master. And a lot of the reason for that is juggling competing interests, positional play against material advantage. I think the same is true in software design. I can teach you the 4 elements of simple design in a couple of minutes, but How do you know when to gather more evidence and when to deal with problems before they get too big? Is it 3 strikes and you refactor? Sometimes it's 4, sometimes it's 2, sometimes you don't refactor at all. And that's what keeps us coming back for more. Now, remember the 3-step process for changing an algorithm. Add the new one, migrate the clients, remove the old one. The easiest way to add the new one in this case is, or I should say a safe way to add the new algorithm is to introduce the lookup table right here, and then to use the lookup table in each branch of the if statement until all the branches of the if statement look the same. And when they do, the if statement disappears. So let's see how that looks. Let's introduce our lookup table. And those of you who aren't working in Java are probably laughing at all the crazy type gymnastics I have to do to make this work. Yeah. We get used to it. So I'm going to create a, let's see here. I'm going to create a new lookup table, and my mechanical naming convention for lookup tables is values by key. So the values are prices and the key are barcodes. So I'm going to call this prices by barcode. And of course, this doesn't need to be a hash map. This can just be a map. So nothing should have changed. I'm not using this new lookup table. And of course, this comment's no longer useful, so I'll get rid of it. And now let's start using this. What I'd like this to do is look up the price in prices by barcode. In order to make that work, the first thing I need to do is to put the price and barcode in our lookup table. Of course, I'm not using it, so I haven't broken anything yet. But I can replace this now with prices by barcode. Get 1, 2, 3, 4, 5. And yes, I've intentionally duplicated 1, 2, 3, 4, 5. We'll get to that in a moment. Well, we can do exactly the same thing for the next body of the if statement. That should still pass. And this can be replaced by prices by barcode get 2, 3, 4, 5, 6. What I've done so far is just change the duplication. Introduce lookup table to replace, oh, let's see here, started, replaced code with data. It's always a good thing to do, replacing code with data. Now what I've done is change the duplication a little bit. I've taken care of the open-closed principal problem, but I haven't removed all the duplication yet. No, I haven't dealt with the open-closed problem, but I have made it a little bit easier to deal with. Now, by the way, here, this else part is really else. Well, actually, let's deal with the duplication part first. So we have 1, 2, 3, 4, 5 here and 1, 2, 3, 4, 5 here, which means that this can just be barcode, and that should still work. It means that this can also just be barcode, and that should still work. But we can't quite get rid of the if statement yet. And that's because of this 1, 2, 3, 4, 5 equals barcode, 2, 3, 4, 5, 6 equals barcode. By the way, for the Java programmers out there, I wrote it this way instead of the other way, barcode equals 1, 2, 3, 4, 5, because barcode could be null, but the string 1, 2, 3, 4, 5 can never be null. So writing it this way means I can never get a null pointer exception. This is not because of the ancient technique from C to help avoid ancient compilers not telling you that you accidentally are assigning values instead of comparing them. And if you don't even know what that problem is, good for you. So now I can collapse at least these two branches of the if statement by taking this condition and moving it up here. So I'll do it in 2 microsteps. And now I can delete that. Now the question is, what does this condition signify? And how is it different from the other part of the else part of the if statement? And what I see is that If 1, 2, 3, 4, 5 is the barcode, or 2, 3, 4, 5, 6 is the barcode, then I have a price. You know, the significance is I have the price. Technically speaking, what does that mean? It means that prices by barcode has that key. So I can replace all this with prices by barcode contains key barcode. That should still pass. Remove duplication in conditions of if statement. Now, the good thing about doing this is now the algorithm is actually fairly clear. If I have this thing that represents prices by barcode that maps the prices to, or the barcodes to prices. And the key is the barcode. So if I have that barcode, then I get its price and display it. And if not, then I display the message, product not found for. And this is pretty straightforward. I can't think of how to make this any easier. So now's a good time to pause, reflect, and we'll come back to this in the next part. We'll look at some duplication between the production code and the tests. This is Jay Brains. I hope you enjoyed this episode, and we'll talk to you again later.